Hello everyone. In this video, we're going to use the disk method or the shell method to find the volumes of the solid generated by revolving the region bounded by the graphs of the equations about the given lines y equal square root of x. How can you graph a function y equal square root of x? First of all, if you construct a small table xy, you can take some values of x like 0, 1, let's take 4. I'll take 3 of them. So if x is 0, y is 0. If x is 1, y is 1. If x is 4, y is 2. Now, when you graph a functions like this, you end up having, let me put it straight. Okay, so we know if x, let's say we have 1 and we have 2, 1, 2, 3, and 4. So if x is 0, y is 0. If x is 1, y is 1. If x is 4, y is 2. Okay, let's say our graph would be this format. Let's consider the graph is like this, or can continue indefinitely. Now with y, they give us the value of y equal, because we have y equal 2, we know y equal 2, we're gonna fall. This is the region, the shaded region we are interested in. Now, I'm going to use this to answer these 3 questions. Would we use either the disk methods, or we would use the shell method to find the volumes? You know, if to find the volume of a solid of revolution with the disk methods, there is a formula that you can use. We're gonna see that. Or to find it using the disk, the shell method, there is another formula. But it all depends of I mean, both of them can give you the same answer, but one is much easier than another one. Let's recopy this here, and I am going just to erase this just to have more space. And let's answer the first questions so far. All right. So what we have for the first question, I'm going to do one slide per questions to make it much easier for us to work, have more space. Okay, this is the graph. Now, with this graph, this is the graph. Now, with this graph, if I change the color, let me take, I'm going to totally change that color. I'm going to take a light blue. All right. Now, we know looking for these questions, because this is the x-axis. So they said it should be revolve around the x-axis. And looking at this graph, because x is 0, it would make it much easier, difficult for us if we use the disk methods here. Because if you use the disk method, you would have the rectangle that would be perpendicular to the x-axis, which won't work here. So it would be better to use the shell methods, where we have the rectangle that would be parallel to the axis we are interested in. So we end up having this distance as our h, and this distance as our p. So we know, using, for this one right here, we're going to use shell method. Use shell method. Now, what is a volume using shell method? Volume using shell method is 2 pi a to b. We have p y h of y dy, because as you see, even though it's revolve around the x-axis, but the rectangle is parallel to the y to the x-axis, so we're going to integrate with respect to y. Now, what is a and b? We already see starting from 0 to 2, so we have a equal 0 and b equal 2. What is p of y? P of y in this case would be simply y, okay? So that would be y value, and h of y would be the x. So what is the x? Because from here, if you raise both, let's say you have y, if you raise y to power 2 and you have raise x, square root of x to power 2, you end up having y squared equal x. So we know x would be equal to y squared. Now that you have p of y and h of y, we can use the volume formula to find the volume. So we go from 0 to 2. P of y is y, and h of y is y squared dy. Now, 2 pi from 0 to 2 would be y cubed dy. Now that we have y cubed, you know how to integrate. We're going to have 2 pi integrate y cubed. It would give us y power 4 over 4. Remember, y power 4 over 4, because it's a definite integral, it's going to be 0 to. When you substitute for 2, 2 pi would be 2 square, 2 power 4 over 4 minus 0 power 4 over 4. Now you know that would give us 2 pi 16 over 4 minus 0. We don't need to write it down. So the volume would be 2 pi times 4. Now, at the end, the volume would simply 8 pi. So this is the volume when it's revolve around the x-axis from 0 to 2. So we said, first of all, you need to decide which methods you're going to use. In this particular case, using the shell method is much easier, because when you have this empty spot between from x equal to 0 to 4, it's going to be very hard to use the disk method. If we answer the next questions in the problem, I think the next questions, if we erase this again, we're going to just try to get more space. Next questions would be to find, all right, let's keep it that way. And again, we're going to keep using the same graph, okay? So if that's okay with you, I don't need to do it so the video would be too long. Now, it tells us to do it with when y equal the line y equal to. So where is line y equal to? This is it. All right, line y equal to. If we revolve around that line right here, again, we see using the disk methods, we're gonna have a big empty spot that would make it more complicated to do. So it would be better that we go with shell method. So we're gonna use shell method here again, because we cannot use the disk method. So at this point, having the rectangle in this format make it much easier for us. All right. And when we do that, what's going to happen with this example, we're going to consider this is our H again, and this is our P with the formula V equal 2 pi from A to B, P of Y. In some books, you instead of saying P of Y, they said R of Y, which is the same thing. We integrate with respect with Y, respect to Y. So what is P of Y in this case? Again, P of Y in this particular case, you see the line, you have the line equal to, you need to subtract the y from it. So that's give you P of Y, and H of Y would be the same thing like we did before, simply equal to X. Remember, we said in this case, X would be equal to square root to Y square. So that would be Y square for P h of y. Now, using the formula, it simply gives us 2 pi 0 to 2, because remember we integrate with respect to y, so 0 to 2. P of y would be 2 minus y, y squared dy. Now, when you distribute, it's going to be 0 to 2y squared minus y power 3 dy. What is v then? When you integrate, would give you 2y power 3 over 3. Okay, that's the first one, minus y power 4 over 4. Okay, now remember it's from 0 to 2. As you see in the previous questions, when you substitute for 0, it gives you 0. So we don't really need to go with 0. Let's just substitute for 2. So it's going to give us 2 power 3 over 3 minus 2 power 4 over 4. Now that we can just simplify, 2 power 3 is 8. 2 times 8 is 16 over 3 minus 2 power 4 is 16 over 4. Because we don't like to deal with decimal, it's better that we find the same denominator. What is the common denominator between 3 and 4? It's 12. So we're going to multiply this one by 4, divide by 4. We're going to multiply this one by 3, divide by 3. So we can bring them to the same denominator. So let's keep our 2 pi outside. We end up 4 times 16 give us 64 over 12 minus 3 times 16 is 48 over 12. Now, let's simplify. Same denominator, we subtract the numerators, 16 over 12. Oh, 16 over 12, again, have a common factor, which is 4. Divide 16 by 12 by 4 is 4. Divide 12 by 4 is 3. Now we can distribute. V would be 8 pi over 3 as a final answer. So this is the second question they ask us. You see the first case we use the shell method, and in the second case we also use the shell method. The shell method, you know, to find it, we can either use the horizontal axis of revolution. Then, as you see, horizontal axis of revolutions we derive with respect to y. But if we did it with vertical axis of revolution, we're going to derive with respect to s. But in these two cases, we do the same. We derive with respect to y. Let's answer the next questions in the problem. So if I remove everything here, it gives me, I would do it with respect to y. Let's do it with respect to y. And we have the same graph. We're going to just keep the graph so we don't need to redo it. So now they tell us to integrate with respect to y. Well, the y-axis. So it's revolve around the y-axis. Now, easy to see if we revolve without, so here, using the shell methods won't work. So we don't need to use the shell method in this case, because remember we're gonna go from 0 to 2, and really using the disk method with a perpendicular rectangular, because now it's perpendicular, we're going to use disk method. Use disk method. And what the disk methods tell us to do, you know, because if you know what to find the volume of a solid of revolution with the disk method, we need to decide either if we revolve around the x-axis or the y-axis. So because we revolve around the y-axis in this case, so the volume, the V volume would be equal to pi AB r square of y dy. Okay, so Now, what is R of Y? So it's all you need to find is what is R of Y. As you remember, X here equal Y square, right? So now what is R square of Y? So that's the first questions we really can ask. So we know it's equal to X, which is Y square. Now, because it's a revolve around it's a vertical axis of revolution, and that's why we derive with respect to y. Now, what is the volume? The volume would be pi 0 to 2. R of y now is y square power 2 because we need to take r square dy. So now we have pi 0 to 2 y to the fourth power dy. That's pi. When you take the antiderivative of y power 4, it gives you y power 5 over 5, something you might probably remember. So what is v? V is pi. When you substitute for 2, it's going to give you 2 power 5 over 5. So it's, and if you plug 0, it won't change anything. So because it's gonna be minus 0, you don't need to do it. So that's what 2 power 5 is 32. So it will be 32 pi over 5. And that's the volume when you revolve around the y-axis, 32 pi over 5. So for some of you, you might consider giving the answer in decimal, but I will strongly advise you to keep it in function of pi instead of substitute pi, symbol pi for 3.14 multiplied by 32 divided by 5. That would definitely be the same answer, but keeping it in function of pi is a good idea. So that's another question. Let's go for the last questions in the problem. If I erase everything here to make sure that we keep the last questions only. And I will keep working with the same graph. Maybe if I have to change it, I will. But so far, it's working for me. And I keep it as is. But look at what happened here. They tell us we need to find a volume revolving around the line x equal -1. We didn't have -1. Let's add it. This is -1 on this axis. So to add the line -1 over here, they said we need to revolve around this axis right here. Oh, look at that. Now, because we revolve around y, x equal -1, we can see also clearly here doing the disk methods would be better for us because we can have our rectangle perpendicular to that axis. And because we know x is y power 2, okay? And the only thing we need to remember here is the washer, because for now we have the washer that is kind of a hole. You see that hole between -1 and the graph. So we end up right using, we can say, we still use the disk because the washer is also the disk method. So that's another method we use, but which is still the disk method. So we're going to use the disk method. But in the disk method, because we have the disk method in itself, and we also have the washer method, because when the disk can be extended to cover solids of revolution with holes by replacing the representative disk with a representative washer. So that's what we do. The volume in this case would be pi AB r square of y minus, because the reason why we said r square of y, we could say r square of x if we did it around the horizontal axis, but you see x equal -1 give us a vertical axis. So we're going to small r square of y. So that's what we're gonna do. we already know AB is 0 to 2, 0, 2. Now, what is the big R of Y? First of all, that's the one we need to identify. We remember we said that the big R can, we've been writing it as X, which is X equal Y square. But now we need to add or subtract -1 to it. So if we subtract -1, is going to give us X plus 1. So R of Y would be what is, we know what is X. X is Y squared plus 1. Now we know because X is Y squared, we just substitute it. Because our functions, if we derive with respect to Y, we cannot have X in that function. So we need to substitute all the X's with Y's because we derive with respect to Y. Otherwise, the X would be a constant. What is the small r of Y? That's the other things you need to verify. Well, what is the gap between from the -1 to where you actually have your graph Y? It's only one. Now that we have both of them, we can write that our volume is pi 0 to 2. Let's say we have Y square plus 1 square minus 1 square, right? dy. That gives us pi 0 to 2. All right, so that would be y power 4 plus 2y square plus 1 minus 1. Remember your identity. If you have, remember if you have a plus b, that gives you power 2, that gives you a square plus 2ab plus b squared. That's how, remember, that's how we get y power 2 give us y4 plus 2 times y2 times 1 give us 2y squared plus 1 squared give us 1. Remember that. That's why you have all of this way. So next, we're gonna simplify because it's still 0, 2. 1 minus 1 is gone. We have y to the 4th plus 2y squared dy. Let's integrate. What you got is y to the 5th over 5 plus 2y to the 3rd over 3, 0 to 2. All right, now we have everything. We can substitute. V would be pi 2 power 5 over 5 plus 2 times 2 power 3 over 3. 0. Oh no, we no longer have that 0 because that's what we replaced. But we don't need to do minus the same thing when you substitute for 0 because we know what it would be. Now we can continue to say we have 32 over 5 plus 16, because remember we said 2 times 2 times 2 is 8 times 2, give us 16 over 3. Again, we end up looking for the same denominator. What the denominator would be in this case 5 and 3. Yes, common denominator would definitely be 5. So we're gonna multiply by 3, divide by 3, multiply by 5, divide by 5. Okay, hopefully we have enough space to do it. So V would be 3 times 2 is 6. 3 times 3 is 9. We have 96 over 15 plus 5 times 6 is 30. 5 times 1 is 5 plus 3 is 8 over 15. Can we just add these two because the denominator is the same? We end up having pi power. Now 6 plus 0 is 6. 9 plus 8 is 17 over 15. Is there any way we can simplify? There is nothing to simplify. Final answer would be 176 pi over 15. So this is the last questions where they ask us to find a volume when it's revolved around the line x equal -1. Hope this helped. Don't forget to subscribe for more video. See you soon.